So for your homework, the first question is, can you figure out what is the probability pulling out of a complete deck of cards, which has 52 cards, 13 of which are in each suit, so 13 hearts, spades, diamonds, clubs. What is the probability, can you figure out what is the probability of pulling out a spade and then pulling out another spade from that one deck if you are replacing the first spade? Second one is the exact same question. What's the probability of pulling out a spade and then pulling out a spade if you did not replace the first spade? Remember, this is and. Second question is, what is the probability spinning the die, assuming, like with theoretical probability, that all areas are equally likely to be spun? What is the probability of getting neither, or getting not yellow or green, in one spin, in two spins, and in three spins? Notice the first one spin, is essentially this. However, when I say two spins, I am introducing the word and. It has to be not yellow or green, and again, not yellow or green. It's going to be a fraction of a fraction. It's going to decrease your chances. And lastly, what's the probability of not getting yellow or green in three spins? In other words, you would have to not get it the first tie, not get it second tie, not get it the third tie. Try. Okay, a little bit more vocabulary, all of which you will need to know. The first thing is the sample space. If you're talking about one die, the sample space is simply the list of all the possible outcomes. All the things that can happen when you roll one die. You can get a 1, a 2, a 3, a 4, a 5, a 6. There's 6 outcomes with one die. This listing is called the sample space, where you list out every possible thing that can happen. When you have two dies, it gets a little more complicated. At first, you could get a 1, and you could roll another 1, and that is the only way that you can roll a 2. Now we're talking about the sums. We're talking about the sums of two dies. There's only one way to get a sum of 2. If you rolled a 1 and then a 2, or a 2 and then a 1, there are two different ways to do that, obviously, and that is where you get a sum of 3. So forth and so on. You notice the most common sum is the sum of 7. That's because whether you're starting with 6, if you're starting with 6, all you need to do is get a 1 on the other die. If you start, so every single side of the die has a possibility of working. Therefore, there are 6 possible ways to get a 7. 6 out of a total of 36. Essentially 1/6 of the time. So for the last homework question, could you please find the probability of rolling a sum of 10, 11, or 12. Notice I said or 12. That's a hint. That's a big deal. Now, needless to say, you're not going to be, this is sort of like replacing, because you can't really take the die once you get the die rolled. So, can you figure out the probability of rolling 10, 11, or 12 for your last question? Okay, so in terms of notation of probability, you will often see things written like this. P, in parentheses, pink. That is red. The probability of getting pink as an outcome. In other words, what is the chances that this spinner here is going to land on the pink section? Now, if we were doing theoretical probability, we might be assuming that all these regions were equally likely to be landed upon. You may have noticed that in some spinners, it's not exactly even or fair, and theoretical probability would not be a good choice if you're dealing with an imperfect spinner. In that case, it would be best to use experimental probability, where you would actually spin the spinner maybe 1,000 times. And after 1,000 tries, you could find out if it really was equally likely for you to get pink as it was to get gray or blue. If it is truly a random and fair spinner, each of these colors may or may not come out to be the same number, but they are likely to be the same number as you spin more and more times. Using theoretical probability, we would say the probability of getting pink would be 1 out of 8. There are 8 spots here. Only 1 out of the 8 is pink. If we're talking about the probability of it being red, and we were doing theoretical again, we actually aren't testing it, so it's not going to be experimental probability, then that would be 2 out of 8, also known as 1/4. When you are spitting, and you're talking about two separate events, there's two very important words to notice. The words and the word or. If we say what is the probability of getting pink and then red, this would be a two-spin operation. As you might suspect, the chances are pretty low of getting pink and then red. Not so easy to do. In fact, it will be 1/8 for pink times 1/4 for red. In other words, only 1 out of 32 times will you wind up getting one pink and one red in two spins. So this does not include one pink and a yellow, one pink and a green, one pink and a blue, so forth and so on. It's just you spin it, you get pink, you spin it again, you get red. Vastly more likely would be the possibility of getting pink or red in one spin. If you look at the red, that's 1/4 or 2/8. The pink is 1/8. So our probability of getting pink or red is that 3 sections out of the 8 are either pink or red. This is a one spin deal, and in one spin, 3 times out of 8 spins, you are likely to get either pink or red. With the word and, it's vastly more difficult because you're talking about 1/4 of the time where you might get red, 3/4 of the time you will not get red. That's called the complement. Complement, not with an I but with an E. Complement, not like G, your hair looks nice today, but complement, meaning the other section of it. If the probability of getting red is 1/4, the complement of that is 1 minus 1/4. In other words, 3/4 is the probability that you will not get red. So naturally, when you say, what's the probability of me getting pink and red, it's super unlikely because you have to get 1/8 of the time when you're going to get pink. 7/8 of the time, you're going to fail right away because 7 other sections here are not pink. But not only that, not only is it 1 out of 8 that you'll get the pink, but then you have to roll again or spin again. In this case, it's only 1 out of 4 chance that you're going to get the red. 3/4 of the time, you won't get the red. So in the 1/8 of a time, one time when you do get it, 3/4 of the time when you spin the second time, you're not going to get the red. That's why it's so hard to get pink and then red, because it's 1/8 of 1/4. So it's 1/32, roughly 3% of the time. If you think about our chart on the other page, 3%, 0.03 is very close to 0. It's not likely that that's going to occur with any frequency.